Hello everyone, my name is Jaysrini. So today I'm going to talk about the problem-based task that was given to us and how I have chosen set A. Okay, this is my instruction set for set A, so which basically has 7 instructions altogether. So the first thing is input R1, 2, which basically means you have to input a data in R1. So 2 is basically from where the data comes from, and R1 is basically the destination. Okay, so the next two instruction is also the same. So it's just that you have to store the data in different registers R2 and R3. So now about add R2, R2, R1 basically means that you have to take data from R2 and you also have to take data from R1 and add both of these data and finally store the answer in R2. And it's also the same for subtraction. Now it's output. Output R2, 4 basically means you have to take the data from the door 4. 4 is basically a door, and then store it in R2 second register and then display the particular data. So that's what the whole instruction mean. And then HLT means how. Okay, so the first thing what happens is after writing the whole instruction set in assembly language in the program, so this is what happens. So the first thing what happens is the program counter will hold and queue the addresses of the instruction set, and it will interpret the each instruction one by one. So then what happens is it will fetch the data needed for each instruction from the main memory. Then it will store in the IR. So what after storing the IR, what happens is the processor will interpret the instruction and detect what kind of action is needed to be performed. For in this case, for the first 3 instructions is input. You have to input a data. So I have input 3 data, which is the first data is 12, second data is 18, and third data is 15. Now what happens is after inputting all the 3 datas in 3 registers is now for addition. So what happens is the program counter will increase through increment, and then it will go hold the address of the particular instruction, which is to add, and fetch data needed for the instruction from the main memory and will store it in the IR instruction register. Then in the IR, what happens is the arithmetic logic unit, the instruction will be interpreted, and the arithmetic logic unit will add 2 numbers from 2 types of register, which is R1 and R2, which is 18 and 12, and the answer will be, which is 30, will be stored in R2. So that's what it basically means. So now for the subtraction part, what happens is exactly the same. The program counter will hold and queue the addresses of instruction, and it will fetch the data needed for the instruction from the main memory. Then what happens is the fetched instruction will be stored in the instruction register, and in the instruction register the instructions will be interpreted, and then the arithmetic logic unit will subtract both numbers, 2 numbers from 2 types of register 3 and register 2, and then the answer, which is 15 and 30 basically, and the answer will be stored in register 2. So yeah, this is what happens in this program counter right now. And now it's the output part. So what happens is the program counter will increase through increment, and it will queue up the instructions, addresses of the instruction, and then it will fetch the data needed for the output instruction right there, and we will store it in the instruction register. Then instruction register will get the read the data from R2 and display it in the input output module. So that's what happened. And then now it's the halt part, where the program will be halt after encountering with this kind of instruction which halts the particular program. That's all. Thank you.